Hi, and welcome to a video on direct variation. In this video, our goals are to identify direct variation equations, write and use direct variation equations, and also use a direct variation model. So the first thing we need to look at is what is exactly a direct variation model. Now, you guys have seen this model, slope-intercept form. Slope-intercept form is y equals mx plus b, where m is the slope or your rate of change and b is your y-intercept. Now, the only difference between slope-intercept form and direct variation form is that your y-intercept is always 0. So direct variation is going to look very similar. In a direct variation model, you're going to have y equals mx plus 0, where m is still your slope, but your y-intercept is always 0. So let's look at some notation and how this is often represented when we're talking about direct variation. Your slope is called your constant of variation. So oftentimes when you have a direct variation equation, you're going to see y equals kx, or you might see y equals ax. But remember, both of those things, the k and the a, they just represent your slope. The reason a k is sometimes used is because k can represent k for constant, and then a is just an arbitrary multiplier that we often use. So don't get bothered by the difference in variables. They still all mean a constant of variation. Now, because every direct variation model has 0 for the y-intercept, every direct variation equation will have the point 0, 0 on it. Because every direct variation equation has the point 0, 0, it's really easy to test which equations are direct variation and which equations are not direct variation. Before we actually look at some equations, let's look at some graphs first. Because the direct variation equation has to have 0, 0 on it, when we look at a graph, as long as our graph goes through the point 0, 0, as it does right here, then we're in good shape. So if I change the graph slope, as long as that stays anchored at 0, 0, you have a direct variation equation. The moment you change the y-intercept, now that graph is no longer direct variation because we don't have the point 0, 0 on the graph. And anything above, these are no longer direct variation because we don't have the point 0, 0. As soon as you get 0, 0 back on your graph, now we have direct variation. Okay? So direct variation, the rule is you have to have 0, 0 on your graph, and then your slope can be positive or negative. So now that we have some ideas about what direct variation looks like, that it has to have the point 0, 0 on it, and that our multiplier, the number in front of the x, is our constant of variation, let's actually look at some equations and decide if they are direct variation or not direct variation. So let's go ahead and decide which one of these equations are direct variation. Go ahead and take a look at them. I'm going to ask you to kind of decide on your own before I go through these. So what I want you to do is, after you hit pause in just a moment, look through, decide with your group, see if you guys can figure out which are direct variation and which are not direct variation. Hit pause now. Alright, let's look at number 1. Now the first thing that we're going to do when we kind of decide these, we want to decide is 0, 0 on the graph. In other words, if we make a little input-output table, if we plug in 0 for x, we better get out 0 for y. So let's go ahead and do that. Y equals 2 times 0 plus 7. When we do this, we get 7. So when x is 0, y is 7. So that is not the point 0, 0, therefore this is not direct variation. And I'm going to use dv for direct variation. So this one is a big no. Now, for number 2, this one you can kind of tell because doesn't it look like y equals mx plus 0? Because we have an invisible plus 0 here. So we can tell just by looking that this is direct variation because it fits this model, y equals mx. Or you could say y equals kx, where your constant of variation is the 6. You can also make an input-output table, and when you plug in 0 for x, 6 times 0 is 0, you did get 0, 0 on your graph. So that one is a yes. If you look at number 3, this, remember, is the line y equals 3, which hits the y-axis at 1, 2, 3, so it's a horizontal line. that goes through the y-axis, and it does not have a point 0, on it. So just by thinking about the graph, you know this is not direct variation. So this one is no. For number 4, we actually have to do some work here, and we have to solve for y. So if we subtract 2x from both sides, you get 3y equals negative 2x, and then if you divide both sides by 3, you get y equals negative 2/3 x. Now again, just by looking at this, you can see that your constant of variation right here is negative 2/3. So you don't have to make an input-output table to check the point 0, but if you want to, you can. We are going to plug in 0 for x. If we plug in 0 for x, negative 2/3 times 0 will get out 0 for y, so it works there. It also fits the model right here. If you go back to what we said this has to look like, it has to look like y equals kx, and it does. Our k is negative 2/3, or our constant of variation. For number 5, this one's very similar to number 4. We have to get the y by itself, so we need to divide both sides by 7. When you do that, you get y equals 4/7 x. And by now you're thinking, okay, I kind of get what's going on here. I have the constant of variation right here. It's 4/7. So for this one, this is direct variation. Also, if you plug in 0 for x, y would be 0. So you have the point 0, on your graph, and your constant of variation, or your slope, is 4/7. And then for our very last problem, if we look at this, this does not look like y equals kx. We have a plus b that is not a 0. Our y-intercept is negative 7 here. So if I test, does this go through the point 0, When I put in 0 for x, I'm going to get negative 7 plus 0. I'm going to get out negative 7 for y. So this is a no. This one's not direct variation. So these were yes. Number 2, 4, and 5, yes, those are direct variation, and sometimes you have to do a little work to get there. But numbers 1, 3, and 6 were not, because they did not fit the model y equals kx. All right, I hope this helped. Keep watching.